Hi, my name's Steve Bell, and I'm doing the podcast today for the Mavericks of MedTech. And this is part one of a series that I'm going to do over the next couple of months. I did an article recently on, why it's difficult to actually commercialize a soft tissue medical robot. And for those that don't know, soft tissue medical robots are those that work in things like laparoscopy, thoracoscopic, and the leader of that category is the Intuitive Da Vinci. I've been asked to do a series on all of the robots that are out there to just talk about my opinions on it. So what I intend to do in these podcasts is to pick one of the robots either on the market or coming to the market and just give my professional opinion on what do I see. Just as a disclaimer, I don't have inside information on these products. I don't have some kind of access or knowledge that's not out in the public domain. It is just opinion. It's from what I see as a professional that's dealt with surgical robotics. It doesn't mean it's actually right. It's just what I perceive and what I see. And you need to make your own mind up about that. And also to invite the manufacturers of the robots or the companies, they can absolutely come back. And if I've got things wrong, they can correct it without problems. They can also, contact me and give me the information so the next time I do it, I can be a little bit more accurate. But this really is just going to be a series of my thoughts on each of the systems that are out there. And part one of this today is I'm going to look at Medtronic's Hugo soft tissue robot and just give my opinion on it. And each of these will be following the same format. And the format that I've got is that I've decided to do is that I'm going to take the architecture of the robot and discuss the architecture of it. I'm going to talk a little bit about the instrumentation that goes with the robot. I will talk a little bit about the digital ecosystem I see around it, because that's, I think, an important piece in today's world of surgical robotics. And then I'll give my opinion, and it's just opinion, on the pros and the cons to each of either the system or the company that's around it that I see challenges that they may have out there, or definite advantages that they'll have with their system. So let me dive right in, and I'm going to talk about the Medtronic Hugo system. So what is the architecture of this system? Well, it's a classic master-slave system. What does that mean for those that don't know? You basically have two major divisions of the robot. You have a console where the surgeon acts like a pilot at the console. And what they do is they give inputs into the console, and then that gets taken to what they call the slave system, or the arms, and the arms replicate the movements. And it's all to do with something called kinematics and reverse kinematics. I won't go into that into too much detail in this podcast. But basically, it's a master-slave system. So the surgeon sits full control of the system from the console, and they basically drive the arms within the patient. That might seem obvious, but I definitely want to make sure we talk architecture. And the reason for that is that I will talk about other systems in the future that are not master-slave systems in the same way. They're slightly modified use of robotic arms to control instruments, but they don't use a master-slave as it is. Hugo is a master-slave. Let me talk a little bit about the console first. So it's what's known as an open console. So that means that the screen is away from the eyes of the user. And like most of these consoles, there is a 3D screen. So there's a screen that's got a polarized screen, and it projects at the same time a left image and a right image from the camera. And you then wear glasses on your face with polarized lenses, and your left eye sees one image and your right eye sees the other. And those images are slightly different from each other, and you get the 3D effect as you look at them. So you have a big screen in front of you, and you sit back and you look through your glasses, and you can see the 3D effect on the screen. So that's an open console. That means that you can look across at the rest of the operating room as you're operating without having to take your head out of the screen mechanism to do that. So you don't wear a headset, or you don't put your face forward into like a binocular vision system. And there are sort of fairly well-known advantages and disadvantages of open systems. that I'll go into a little bit later in the pros and cons. But that's what they use. And then you have a set of hand controllers that you have. They have small pistol grips that you can then control the left and right arm, and you can then decide which left and right arm that controls of the robot. You can select which arm you have it controlling. And then what you can also do is you can control the camera from there as well. So you get full control from the console of the camera and a set of instruments that you then have inside the patient. And that's the general architecture of the console. Then what you see at the Hugo console is that they also have a set of foot pedals. So they have controls with their hands, but then you use your feet to control things like clutching, which is the disengagement of the movements while you reposition. It will do the electrosurgery controls. It will also do some firing later on, it looks like, for their ligature and potentially their staplers later. So you've got this footbed with different buttons on it that you then use with your feet. So you use a combination of hands and feet movements to control the instruments, drive the instruments, power the instruments, and that's the basic architecture of their console. Then, like many of the robots, they have a secondary piece of hardware, which is the tower. And on that tower, there's different computing power that's in there. There's usually a secondary screen, and they have a secondary screen on it so that you can watch the procedure from that screen. But you can also give some inputs to it from what I can see on their architecture. And there is a rather large, heavy computing unit in there. And I'm presuming that there's a lot of the computing power is done on the tower, not on the actual console, and not so much in the robotic arms. So you basically connect the console through a set of cables. You connect that to the tower. So one of the things that I'll just mention here is that the more modules you have, the more arms you have, the more carts you have, the more towers you have. Every component that you add on that requires cabling to get it together is so the problem is that cables are already a pain in the operating room. And the more of these cables that you have lying around, and some of these are pretty thick, like all modular systems, cable management becomes a problem. So yes, you get the benefit of the modular arms, but now you start getting problems with cables and cable management. Then you have the rest of the hardware, which are the arms. And I'm going to talk here, because this is the first podcast that I'll do on this, a little bit of the architecture of arms. There's different things that you can do. So what you can do is the classic that you see with the Da Vinci is that they have a central tower or a boom, and from that boom you hang all of the arms from above the patient, and they hang down over the patient, and you can have 4 arms, for example, with the XI, that hang in an X shape above the patient and reach down to the patient. The next architecture is that you take each of those arms and you either mount them on the bed independently, which is something that's coming, but it's an old way. It's actually one of the originals from the computer motion Zeus. But then the second way is that what you can do is you can mount them onto individual patient carts or bedside carts, and each arm is on that cart. You position the cart around the table and you bring each of the robotic arms, or as many as you want of them, to the patient to be used in the procedure during the case. Medtronic, they have 4 arms or 4 base units that they can use, and you can use one or all of them at the same time around the patient, depending on the case. They basically have a base with wheels on, so you can move them around. And then hanging off that then is the fancy part, which is the robot arm. One of the features that I've seen with Hugo is that you can do you can put the scope or the instruments onto any arm, so they're agnostic to whether it's the scope or the instrument. And I think that's important, because when you're doing multi-quadrant procedures and you need to move the scope around, then you're able to just unclick the scope and move it to another arm. What you don't have to do is then take that modular arm and move it around the patient to be able to bring the scope in from another angle. And I think that's a very nice feature. And there's a few robots out there that can do that. And this ability to move the scope to any arm, I think, is a really nice feature on Hugo. There are other architectures that I won't go into today, which is where you've got like small standalone robots. So you've got virtual incision or vicarious surgical. They are small independents where the whole modular thing goes in. And also Intuitive does have a system where they have the SP, which is a single port. And I won't talk about that today, but I'll get into that architecture in another series of podcasts in the future. So when you look at Medtronics, they have these carts, and then coming off them are the arms. This is where I'll talk a little bit now about what I see as their architecture. So what I found very interesting with Medtronic was that they opted for a non-collapsible Z-rail, which I found very interesting. So what do I mean by that? So the terminal piece of the robotic arm, the end piece that holds the instrument, is called the Z-rail in some architectures. And it's called the Z-rail because it gives the Z-axis movement of the instrument, which is the kind of in and out of the patient. And if you look at images of Hugo, what you'll see is that end terminal piece where the instrument attaches to, and then you've got the instrument drive pack, which sits up at the top of that Z-rail. And that, for me, is a fairly large and big drive unit, which clearly means that they're going to use it to drive staplers in the future, because you wouldn't need such a big, robust drive unit to be able to drive standard instruments alone. So they've obviously thought about that for driving their staplers, the drivers of the staplers and the blade in the staplers. The problem, though, with that I see is that when you put such a huge weight on a non-collapsible Z-rail, i.e. the Z-rail remains long no matter how you're using it. The problem with that is that all of this is going to be used in laparoscopy. And that means that you have the laparoscopic instruments that hang off the end of the robot going through a trocar, and they go through a pivot point in the patient. And like any lever mechanism, you basically, if you want the tip of the instrument to move left, you move the outside of the instrument right. If you want it to go up the tip, then the outside of the instrument goes down. Basically, it works as a lever, so that if you have a very short amount of instrument inside the patient, you will have very large movements required on the outside of the patient. And what that means is that the longer that you make that whole mechanism from the tip of the instrument to the back of the Z-rail, the larger the Z-rail moves around in space. And when the Z-rail is making large movements in space, you have to look at the speed at which you want that Z-rail to move to be able to keep the tip movement at a high speed as well. And there are limits that you're allowed to do with that. The problem that I see there is that you end up with you can potentially, and what I've seen from the videos, you end up with massive movements of the Z-rails outside of the patient if you're not deep inside the patient. And if you've got 2 or 3 arms moving together like that, then that you can end up with something called clash, which is where the arms outside can potentially clash with each other. And I've not seen any evidence of anti-clash software, i.e. each base unit knows in space where the base unit is, so therefore makes some kind of software adjustment to make sure that the arms don't clash into each other whilst the arms are moving. So I think that's a little bit of a challenge that I see there. And the biggest challenge for that is that, you do have somebody at the bedside, which is the bedside assistant. And I would just be a little bit concerned that at head height, moving around at speed, are these fairly heavy instrument drive packs that are swinging around on these fairly large arms. Fine when you're down deep in the pelvis and you're doing small movements. But I think in some of the big multi-quadrant surgeries, I would be a little bit concerned at the speed that they would be moving around and having the bedside assistants too close into them. But again, I'd like feedback if that's true or that's just my perception as I see it as an external observer. Now, the second issue the good thing about that is that it's a very well-known and a very well tried and tested system of having this kind of Z-rail and having your instrument pack mounted on the Z-rail and using the robot in that fashion. It's just very well known, and you can get very good accuracy with the movement of the in the Z-axis that way. The challenge that then creates, though, is several folds. So the first thing is when you end up with these long Z-rails, you often end up with a very, very long instrument. And that's quite interesting because that gets spun often as, we have more reach. Well, no, that's not true. The problem with the whole mechanism is that you attach a Z-rail to the trocar, and therefore you have the secondary limits that are put onto the arm and the instrument path because of the attachment to the trocar. So you end up with, there's 2 things you have to look at when you look at instruments on a robot. You have to look at the real length, so measure the length of the actual shaft of the instrument. But what you have to ask is, what's the effective working length? So that is the length that the instrument can go from the pivot point at the patient's abdomen and how much of that instrument can be used past the pivot point. And that will give you the effective working length of the instrument. And there's two parts to that. One is how far it can reach down into the patient is one part of the working length that you care about. But the second is what's the limit of how close the tip of the instrument can come back to the pivot point. Because if you're working up in the abdominal wall, you're trying to work on the anterior surface of the abdominal wall, then you can end up having limitations of movement because you can't get close enough to your trocar. So I've not determined totally what the minimal limit is on, and I've, I probably will go and measure at some point the working length, the effective working length, and I can probably work that out from some videos that I'll look at. But that's one of the things. So you end up with very, very long instruments, and why that's a problem is that these are hollow instruments that have down the center of them in this type of fully wristed instrument, which I'll talk about in a minute, is a set of cables. And you have a set of cables that go down there. You have some other channels. You might have some electrosurgery cables that go down the center of the instrument. And basically, you end up with an 8mm instrument with a center. And the longer that gets, the harder it is to clean out inside. And one of the biggest challenges at the minute that I'm seeing in the industry is that the cleaning and sterilization specifications for instruments is going up. And if you look at Germany, they have super high specifications. FDA also just changed their specifications, just makes it harder. So they look for how much bioburden is left inside instruments, all instruments, not just robotic. The challenge is that the longer that you make your instrument and the narrower you make your instrument, the harder it is to clean out the residual bioburden that you get in there. And the reason you get bioburden in there is predominantly because you're working in a high-pressure CO2 environment that forces blood and fluids back up the shafts of instruments. So again, I see them as having long instruments. And what I've heard, and again, please correct me if I'm wrong, but I've heard that they are meant to be multi-life, but at the minute, there's a limited number of lives that are being put onto the instruments with Medtronic. And I don't know if that's because they're struggling or there's a problem or it's difficult to clean within them. Could be that. Or it's just that they're being very cautious. And the problem with cable-driven instruments that have cables inside, which I'll go into detail in a minute, is that cables stretch, the tension changes. What happens is that you then can lose some of the precision at the tip, or worse, the cables come off or the cables snap. So maybe Medtronic are just being extremely careful at the minute and limiting the number of lives so that they make sure they get really good performance out of each instrument as it's used. Or it could be that, it's just difficult to clean inside them or to pass the bioburden. I don't know. And if somebody knows that, then please, they can comment. Again, as this is the first one of these that I'm doing, I will talk a little bit about instruments and instrument architecture as we get into that. So one of the main reasons you buy a robot is because you want to have flexible tips. And I'm using that term in a really wrong way. What I mean is that people want the tip to be able to move at different angles so they can get around structures, or if you're suturing, you can make suturing easier because you can approach the needle at the right angle and you can tie knots. And I'm being careful in my choice of words here because there's articulated, there's flexible tips that do that, there's fully wristed tips that do that, and there's combinations of these that try and get around or to give you that kind of flexible or wristed movement at the end. But each of them is very different, and I think that's been some of the problems with some of the systems out there. So the gold standard that's out there today that comes from Da Vinci is that you have a fully wristed instrument. What does that mean? So that means that on the end of the shaft of the instrument, classically in laparoscopy, the jaws are fixed and straight. And back in the early 90s, companies like Ethicon Endosurgery and US Surgical, they came out with things like Roticulator, which were laparoscopic hand instruments with flexible tips or angling tips, because they understood that in certain circumstances, trying to get the right approach of angle of the tip to the tissue was really important, but it never really worked. One of the breakthroughs that came was through computer motion and through Intuitive, was when they put on various types of wristed instruments. And the Intuitive wristed instruments, the way that works is that you have at the end of the instrument, you have some different joints, and those joints are moved by cables and pulleys. And I won't go into too much technical detail now, but you end up with what you want the instrument to do is to be able that the tip can move left and right, which is basically what they call yaw, or you have at the same time, you want to be able to also independently move the tip up and down, which is pitch. And you also want to be able to roll the whole instrument. So you have pitch, yaw, and roll. And that should allow you to get your tip into any position you want at any time. That's the gold standard is what Intuitive does with that. And they do that with a set of cable mechanisms that through the drive pack of the motor, they drive the cables and they allow this, what they call fully wristed movement, which is replicating the wrist of the human surgeon. And that's why it's so pleasing to a surgeon to use those wristed instruments, because they feel like they can get all of their movements they would use in open surgery back into laparoscopic surgery. So now you have the combination of stable 3D vision, as you would have in open surgery, with wristed instruments inside the patient, as you would have in open surgery. And what the robot does is it allows you to get rid of all these reverse movements. So with laparoscopy, you've got to learn to go up to put the instrument down, left to put the instrument right. Instead, the beauty of the robot is that you move the controller up, the instrument tip follows your hand and goes up, because the robot works out all that complex maths in between you and the patient through the fulcrum and makes those movements. And what I see in Hugo is that it mimics quite well the architecture of the Da Vinci, and you get fully wristed instruments that are on the Hugo. And they seem to be 8 millimeters, which is a similar diameter. So they've got sort of similar length, strength, and wristed capability. And then they have the classic tips on the end of them that a surgeon would want. So I've seen that they've got a limited number of tips on their wristed instruments. So they've got, the classics. So they've got needle holders, they've got scissors, they've got graspers, they've got Maryland bipolars. The one interesting thing that I've not seen so far is a hook. And I'll dig into that a little minute. So that's a monopolar hook, which is a fairly well-used instrument in things like laparoscopic cholecystectomy. So I'm going to speculate here. I do understand that making a monopolar hook is really difficult. And people say, well, they've got monopolar scissors. The difference with that is that in the scissor, you end up putting a sleeve over the wrist to make sure that as you put the monopolar power through the tip of the instrument, you don't get errant electrosurgery burning things. It's really difficult to make a monopolar instrument like a hook, and even laparoscopic instruments have struggled with it for years, because you can end up with arcing, or you can end up with insulation breakdowns, etc. So I don't know, but I've not seen a hook so far. But again, correct me if I'm wrong, if that hook is now available. In my last knowledge, I couldn't see that the hook was out there. So I think that's a little bit of a limit. So what generally you end up with Hugo is that as of today, they have very limited wristed instrument configurations compared to an XI. And they probably have the instruments that are used the majority of the time. But, you end up with about 20% of procedures where you could really do with having extra access to more instrument tips and instrument types. So it'll be interesting to see how they evolve that. So that's where we talk a little bit about what I would say the basic knives and forks of their offering. Now, interesting, what they do have is they have an adapter for some reusable, I think it's Stort's instruments, so they can put reusable tips from Stort's onto their robot, and you can then use a whole range of straight stick reusable tips on their platform. I struggle a little bit with that because, whenever I've talked to surgeons over the years, they really want wristed instruments. That's part of the reason you make such an investment into a robot. And I understand the logic, which is, well, for certain things like grabbing the end of a gallbladder or grabbing, a chunky piece of tissue that you're going to take out, there's no problem having a straight stick. So it will be interesting for me to see how much that gets used in reality and how much people actually really do use those ancillary straight stick instruments in their procedures, or whether people just really want the wristed instruments. That then takes me to advanced instrumentation. So one of the things that Hugo's been touting is that they will have a range of advanced instrumentation that comes out. That's going to be interesting to see, because Their premium product, which is a beautiful product, is their LigaSure. And the LigaSure, though, has one of the problems which robots don't like through wristed instruments, which is if you try and wrist something like a LigaSure, you also have to wrist the blade actuation mechanism. And then that makes the joint that holds the tip very, very long, and that becomes a problem. The initial video that came out of Hugo it has on it a few seconds of showing the tip of a LigaSure. I, again, stand to be corrected, but that looked to me like that was somebody holding a manual LigaSure through a trocar, because you didn't see the robot end of it. You only saw the patient end of it. The way that it was vibrating in the video looked like it was a manual tremor on it. So maybe they were just showing of what's coming in the future. But I think if they come out and they're going to end up with a LigaSure, I predict that unlike the Da Vinci bipolar system, this will be either they will end up with a very, very long tip, or they're going to end up with the first generation coming out being straight. And if it's straight, there's debate out there whether using a wristed grasper with a straight instrument would give you the same kind of ability to get tissue in as using a wristed advanced energy device. So that's going to be an interesting one to watch. The next table stakes that kind of come out in this is stapling. And Medtronic are renowned for having their excellence in surgical staplers. So they definitely will be bringing staplers onto the device. Now, what I can see from the outside is they keep touting that we will be the only company giving open laparoscopic and robotic abilities. And I deduce from that what they're going to try and do is they're going to try and take their Signia stapler reloads and they're going to put their Signia stapler onto the robot. And if they do that, I think they're going to struggle. And let me tell you why. So if you look at the gold standard today is the Da Vinci stapling systems, which is the short form, which is beautiful in terms of the way that it moves. The wristed capability of that stapler is par excellence. Whereas what I see today is that the Signia tends to be a yaw movement only, and it's quite slow, and it's kind of motor-driven yaw, not a cable-driven wrist. That's okay in laparoscopic, potentially, because you can make these fast movements and you can sort of move your hands outside pretty fast. If they come with being able to take the same sort of laparoscopic reloads for the Signia and try and adapt that to put that or similar onto their robot, if they do that, and I'm not saying they will, it's just only what I can see so far, you're going to end up with very slow movements of yaw within the patient. And I think that will be highly frustrating for surgeons if they try and do that. I think that they will be, it might work, but I think there might be some frustration. But what you will end up with, though, is that the quality of the Medtronic staples and staplers will be brought to the robot system, and some people just will not want to change away from their tried and tested Medtronic brand of staplers. So I think that that's a big thing that they'll have going for them if they get that on eventually. Probably more difficult than you think to get that on. But I can foresee that they'll have more wristed instruments coming. They'll have a LigaSure. They may have in the future a wristed LigaSure or a flexible LigaSure. They will bring staplers out. I imagine their first generation would be based on the Signia platform, so therefore will be a little bit slow and not so articulating. And maybe the amount that it articulates might not be enough. And then eventually, I think what they'll have to come with is what will be the table stakes, which is a fully wristed stapling architecture that they can put onto the robot. I'm going to dig in a little bit now into their vision system, because I think vision is an important piece. So clearly 3D HD, which is, again, table stakes. If you've not got that today, you shouldn't bring a robot to the market. They don't have, as I've seen today, any kind of fluorescence imaging. So they've got an older system from Storz, from what I can see as their imaging system. They don't have fluorescence or ICG today, which is strange because, Rubina is out there, which I think is probably one of the gold standards for fluorescence imaging and just imaging today. So maybe Storz didn't give them access to their latest and greatest system. They did buy an Israeli company, or it was an Israeli originally based company, which I think was called Vision Sense or Vision Science, can't remember the name. And that did have fluorescence within it. So I know they've got capabilities to do fluorescence imaging. So I imagine that in pretty soon they'll bring that out so that you can have fluorescence, which again is going to be a table stake in the future. If you've not got fluorescence imaging, then you're going to be behind everyone. I mean, Intuitive today has Firefly, which is a black and white with a color overlay, which is a little bit old-fashioned. It's an old Novidac-style system back from the day. Firefly, the table stakes are going to be full-color overlay ICG or fluorescence imaging in the near future for everybody. That will just be table stakes. So I imagine they're working on that, and they're going to have that coming out soon. There is one issue of their imaging system that has been told to me is a little bit annoying, which is when you're the pilot of the Hugo, your glasses are slightly different than the people who are sat around looking at the open console, which is one of the advantages of an open console. Multiple people can sit around and look. So for teaching, it's just brilliant. You don't need a second console for people to look into for teaching. But what you do is you have two white dots on your glasses, which are reference markers for their safety system, which basically, if you look away from the screen, it then disengages the robot from as their safety mechanism to make sure that, the pilot is concentrated in on the screen. That kind of negates a little bit the whole benefit of the open console, because quite often with an open console, you'll want to be able to look away from the screen, but do a maneuver so that you maneuver the external robotic arm so you avoid a clash. And the problem with that is that if you look away from the screen here, and I don't know what degrees of angle, so again, anyone from Medtronic can answer that. But if you look away from the screen enough, the robot will disengage, and therefore you can't actually do the maneuvering of the instruments to try and keep the arms out of clash. So I find that a little bit weird. And I've had some feedback from surgeons who say they find that a little bit annoying, that when they look across, it disengages and they have to re-engage back in again. A minor point, but it's connected to the vision system. Yeah, nice screen, good screen, large size screen, good bright image, and a fairly decent image coming out of the store system that you see with that in 3D. Very, very nice imaging system. So let me talk a little bit about some of the pros and the cons of the system from my perspective. One of the big pros of Medtronic Hugo is the name Medtronic. If you've got this large, well-trusted, super good brand behind your robot, that's an instant amount of credibility that the company behind it is going to be able to give good training, education, support, etc. It doesn't guarantee that your robot works, by the way, but it definitely guarantees that the company behind it is a really credible, good company, which I think is a really good pro. The second thing that they have is that because they're Medtronic, they do have the knowledge of both open laparoscopic procedures. They have a very good knowledge of that. Instrumentation is very good. And what I see is that the tips on their instruments look really, really good. And I wouldn't expect anything less from Medtronic to have really good tips on their instruments. Doesn't mean that the range is there at the minute, as I spoke earlier, but they definitely, what they have on there seems to work well, seems to grasp well, hold the needle well, and seems to work well, which I think is, what I'd expect from Medtronic. The other pro is that, the system is it looks fairly chunky and fairly robust, and that's a pro and a con, and I'll come to the con later. The pro of it is that you've got a lot of mass on each of those carts. So therefore, you should effectively get a lot of stability from that. And it looks like the actual cart bases are stable. The other pro for them is that the console looks like, it just looks like beautiful build quality, and the haptic arms look like great quality. And they've got really nice little controllers on there that I've seen for the way that you control it, and the pedal architecture, the quality of the pedals. All just looks very, very good. It's what you'd expect to come out of the house of Medtronic, is such a good quality of external casing, buttons, switchgear, haptic arms, plastic moldings. The whole thing looks like, a professional built robot, which is what you'd expect from Medtronic. I'll sort of give them a plus and a negative on the movement of the instruments. So the stability of the system usually and generally gives a very stable instrument movement, i.e., somebody knocks the cart because it's so stable and big, then you shouldn't get much vibration going off down to the instruments. And I've not seen much evidence of that. But the problem is, what I talked about the Z-Rail earlier, is that because it's so long, big and heavy, it feels, and again, I can only say this from having seen it in the operating room, and I've not driven it personally, is the movements, I think there needs to be a lot of compensation because of momentum that builds up in those arms there in certain poses when the arm's set. So it'll be interesting to see how they keep adapting that with software. Coming to the software that's on the system, the one thing that I struggle a little bit with is their boot times of the system. It felt really, really long. It felt like it was almost like over 10 minutes long to boot the system and get the system architecture up and running. That, I think, is a potential issue, which is all robots fault at some point. There's either a medium priority alarm or a high priority alarm at some point, either through a clash or through just the safety software kicking in. The problem with that is that if you ended up having to take all the instruments out, take the arms away while you reboot the system, that's going to take you 5 minutes or so from what I can see. And then if you've got like a 10, 15 minute boot up time on the software, you're now talking about 20 minutes of downtime in anesthesia. Again, maybe it was a perception that I've had, but some surgeons have said to me in the past that they felt that the boot up time was way, way, way too long. And again, with modern software architectures, I don't think there's a reason why you have to have it so long to boot up. So maybe that's something they're working on. Maybe that's a software patch they'll do in the future. But that was just one of the things that came back to me. And I personally observed it and thought, that's a very long boot up time. Wouldn't want the patient sitting there while they're booting up that system. One of the downsides of this is that, Hugo, it is modular. So you've got the complexity of the modular. You have to learn where to put the modules, each of the arms, to be able to get the best use. The large movements of the arms outside and just their architecture ends up with the fact that you are fairly, and I'm reading their manual, it's fairly restrictive on where you can and can't put the trocars. The distances between them and hard structures, either distances between trocars or distances between hard structures, seems very excessive. And I can imagine I'm presuming it's a result of the fact that they have the way that their arm movements are, and you're using Z rails. If you use anyone who uses Z rails ends up with limits of trocar placement, including Da Vinci has some limits on trocar placement. And I've definitely seen that in Medtronic's suggested layouts and stuff. So I think that could be a problem. Fairly easy in certain where you're doing one single quadrant and you're working in one direction. I think limiting trocar placements is okay. But again, surgeons just don't like to change their trocar placement. And then the problem comes in then if you have these extra long robotic instruments to get the reach, and then your trocar's put in a place where you can't then bring in a manual instrument. I think that in some cases to do what people call hybrid procedures, or where they have to use laparoscopic intervention with handheld instruments in the robotic procedure, I think you may struggle with some of those trocar placements. So that's a negative that I've seen there, is that the positioning of the trocars is fairly linked and fairly limited by the architecture of the system. My next observation is just that, if you end up with these big, long, non-collapsible Z rails with a heavy instrument pack on the end, you end up with a heavy arm, a heavy Z rail. So you have a heavy Z rail, you end up with bigger arms that have to support it and hold it in 3D space all the way back to the cart. And therefore, if you've got all this mass hanging at a long distance from the patient, you need a very big and heavy cart. Two things with that. One is the weight of the carts seems very excessive to me. And the second thing is the size of the footprint of the carts. The actual baseline, to make sure that they don't tip over because they become taller, they become bigger, they become heavier. There's limitations then of how you get them around the bed. Now, the answer is, well, I can put them further from the bed because they've got longer reach, because they've got these big, heavy arms. But then you start invading into the operating room real estate, and bedside teams start getting pretty upset about that. So I've seen that the size and the mass of the Hugo individual arms seems to negate the modularity, then becomes less beneficial because you're ending up taking up so much real estate. It also means then, again, storage of this in a storage space becomes a problem, and that's problematic if you look at places like ASCs or you look at small operating rooms. When they get audits, they have to be able to show that there's not cluttering and that they're not cluttering up the OR. So the size of the thing is, I think it's a limitation on the Hugo system. And obviously somebody in Medtronic's marketing knew that, because when they brought out their first renders, and you can go and look at the first renders that they did, what you need to do is you need to look at the number of arms, and each arm should have 4 wheels on it. When they did the render, they put all the arms out, but somebody used Photoshop to remove some of the base parts of the wheels to make it look much more compact. And that to me was a very early indication that they were already themselves concerned about how big this might appear and then the size of it within the operating rooms. I think that what they might be able to do in the future is make a collapsible Z rail, which is slightly lighter, use a slightly smaller, lighter instrument pack as they, as motors improve, power management improves. And what they should be able to do is make those arms smaller so they get more and more of the benefits of the modularity. As I'm wrapping up, I'll talk a little bit about their digital architecture. So they acquired a company called Touch Surgical, and Touch is a video recording software, and I'm sure there's a lot more stuff in the back of it from the days that I originally saw it. And basically what they do is they use image identification, they take it up, they can analyze your cases through that, the benefit of that is that you can, even if you bring laparoscopic instruments in that are not attached to the robot, you can get identification, you can work out a lot of things from the image. You can work out segmentation, you can work out procedure segmentation. There's all kinds of things that you can do when you use imaging identification as your means of collecting data. My understanding is, though, that the robotic arms themselves don't throw off much data, or I've not seen any evidence that they throw data off that matches up with the image. And I find that a bit strange, that the robot doesn't collect all of its kinematic data and throw it back to the user so that you can start to look at things like how your hand movements, because, Touch Surgical won't record the hand movements of the user and then start mapping them to clinical outcomes. The things that you did as an operator, the amount of force you put on or tension that you put on tissue, the grasping forces, things like this, that I think that when you don't have your robot throwing that off is one of the challenges that you lose half of your data and throw it away. So it'll be interesting to see whether they do allow that to, whether that's embedded in there and they just haven't implemented that yet. But it'll be interesting to see from the Touch side of it, whether there's enough data in there for that to be a compelling suite of digital products that'll come out of that. Now, they do have a registry, and I think that the registry is going to be table stakes as well, the robotic registry. And I think that'll be interesting as well when they start putting that together with Touch's data, and you'll start to be able to do some data that matches up with clinical outcomes. I think that will be a very important and powerful piece of anybody's digital architecture. And then all of that data needs to be given back to the users. And I've not played with their app, so I've not seen what's on there, but they've obviously understood that imaging video data is going to be important to the users, and it looks like they're setting themselves up well, and they're doing some tuck-in M&A that seems to be looking in that direction as well. So in summary, what do I think of the Hugo? I think that it's still early days for them. I think it's a big architecture and heavy architecture, and they need to get that be lighter and smaller for it to get real mass adoption everywhere, including some of the smaller operating rooms and ASCs. They're going to have to expand their instrument range for wristed, and I don't think that the straight ones are going to cover not having the whole suite of the wristed instruments. They need an advanced energy device and a stapling device, and it'll be interesting to see how they try and adapt those onto the system. And they have an open console, which I personally am a fan of. I just like that kind of connectivity and hearing from the operating room staff, so I think that's good. And it's Medtronic behind the Hugo, and they're not going away anywhere tomorrow. And any issues that they have with their system, and every system has issues, that Medtronic will sooner or later work out and fix it. So one of the big advantages that Medtronic has is that they are Medtronic and they have huge channel and reach. That is very important. They already have the training rooms and systems in place, so that's going to help them as well. But what I think it is their ability to put together offers and deals across their laparoscopic, their open, and their robotic, I think will be a very important tool that they can use that a lot of the other companies will not be able to use. There's probably only Johnson & Johnson that could be another company that could do that in the near future. But I think that ability to group products together and give better discounts or give better offers, I think that that's also going to be a very powerful thing. So besides the actual architecture of the robot itself, I think their commercial ability is a very important piece of what Medtronic has to offer. So that's my personal review of Hugo, and from what I've seen, and again, may have got some things wrong in there. So it's just my personal interpretation of the Hugo system, and I will do more of these. And in the comments, if anybody has different information, please correct me. And if you're a user of it and you want to comment about anything that I've said, then please do. And if you find these insights useful, you can join me over at howtostartupinmedtech.com, where if you're starting a company and even a robotics company, you can get all the advice that you need on how to start up a successful medtech company.